Hello everyone, happy holidays. My name is Luis Beltran. I am a Microsoft MVP in Developer Technologies and Artificial Intelligence. And today I'm going to talk about Azure Cognitive Search, a service that you can use to add intelligent queries into your data. What is more impressive about it is that you can search not only from databases and tables, but also from unstructured data, such as PDF, document files, images, you name it. This video is part of the Azure Advent Calendar initiative by Richard Hooper and Gregor Soddy. Thank both of you for coming up with this great idea and also for inviting me to participate. The Azure community has been really supportive and collaborative with videos and blog posts every day so we can learn about new topics. Visit azureadventcalendar.com for more information about it. Keep up the good work, guys and girls, and let's get started with our topic. When we take a look at a company's sources of information, we are going to find out that while data is normally stored in a database, the real value is found in documents, such as invoices, receipts, meeting minutes, business plans, emails between customers and the company, product information, product photos. Even their website contains a lot of information. Basically, around 80% of a company's data is presented in unstructured data format, images, documents, and when you are looking for information there, it is not an easy task as it would be for a database, where you can perform a query and get results. So the problem is, how would you build a software that can search for information within documents, within a PDF file, for instance? The answer is with Azure Cognitive Search, which is a smart service with powerful features such as keyword search, autocomplete or suggestions based on the main content, context-relevant searches, for instance by considering the geolocation of a person, synonyms capabilities, and many more. Azure Cognitive Search is part of the Azure Cognitive Services suite, and you can even combine them to create a powerful search engine, for instance by adding optical character recognition, OCR, to identify text within your images, or also by including speech transcription to search by your voice. What about translating both the search terms and results from one language to another? Well, that is also supported. Azure Cognitive Search is a concrete implementation of the ingest, enrich, explore pattern. Ingest means that you pull your data from your SQL DB, Cosmos DB, MySQL, table storage, and even Azure Blob Storage. Actually, for unstructured data in the blob storage, the service not only reads the raw data, but also supports content extraction from several file formats, such as Office documents, PDF files, HTML content. And you can get text, metadata, and even extract the images within a document or a website. Enrich means that you can use skills, in this case cognitive skills, to augment data as it is ingested using a powerful composition system. This is what I mentioned in earlier slides, where you integrate the solution with cognitive services to offer OCR capabilities, language detection, or even image analysis. It is extensible, So you can also roll your own cognitive skills from your Azure function code or even another service. So let's say that we have our information in English. We have documents, we have text from databases, and we would like to offer search capabilities in Spanish, in a different language. So we can create an Azure function which takes input, text as an input, and generates output in a different language. After we create this code, we can connect it to our Azure Search, cognitive search, through a custom translation skill. Finally, for explore, the outcome of the enrichment stage is the additional knowledge derived from the ingested data, combined with the outcome of applying several artificial intelligence models to it. Different applications would like to surface different exploration experiences over this data. The original information and all annotations produced during the enrichment are put in an Azure Search index, which is a powerful data store with keyword search support, understands more than 50 languages, can query both structured and unstructured data, and also has faceted navigation capabilities. First of all, you provision an Azure Cognitive Search service from either the portal, or there is also a resource management API. When you create this service, you can scope capacity, you can bound it to a region, and you can also create keys, indexes, indexers, and data sources. More about it in the next slides. It has also elastic scale capabilities like any other Azure services, and you can scale this capacity for query and index workloads by modifying replicas and partition values. A replica is a copy of your data that allows Azure Cognitive Search to load balance requests against the multiple copies. A partition is a mechanism for splitting your data across extra resources. So, for example, adding a second partition splits data into two. A third partition splits it into three, and so on. The main advantage is that slower queries perform faster due to parallel computing. An index is a persistent store of documents and other constructs used for filtered and full text search on an Azure Cognitive Search service. A document is a single unit of searchable data in your index. The fields collection is the largest part of an index, where each field is named, typed, and attributed. It supports strings, booleans, list of strings, numeric data types such as doubles and integers, and even other complex data types such as datetime offsets and geographical points. Regarding attributes, a key is a string that provides the unique identifier of each document and is mainly used for document lookup. Every index must have one key, and only one field can be the key. The type should be string. A field can also be retrievable, which means that it is the file that can be returned in a search result. It can be filterable, meaning that it allows the field to be used in the search queries. It can be sortable, So we can order search results using these fields. It can be facetable, which means that a field can be used for navigation structure, such as categories or fields that contain repetitive values that you can group multiple documents later. And if a field is searchable, it means that the field you can use full text search over this field. Linguistics are key in Azure Search. As we said before, there is support for more than 50 languages, and in this case, a relevant topic is an analyzer. Analyzers are components of full-text search engines responsible for processing text in query strings and index documents. Every analyzer manipulates text in different ways depending on the scenario. Azure Cognitive Search uses the Apache Lucene Standard Analyzer as the default, which breaks text into elements following the Unicode text segmentation rules. In general, any analyzer in Lucene is tokenizer, which means that it splits the text into chunks. Then we have the stemmer, which gets the base of a word. And there are also stop words filtering, which removes the most frequent words in sentences, such as articles, prepositions, pronouns, which might be non-relevant for the search query. We can also use, as an alternative, Microsoft's own analyzers, which are part of the Office and Bing search engines. For the index data process, you can use the portal or the API to perform operations over the index, such as pushing data to an index, rebuild an index, upload, merge or upload, and remove documents. Moreover, you can retrieve data from well-known sources through indexers, such as Azure SQL DB, Cosmos DB, table storage, and also blob storage. All indexers support scheduling, so that you can specify how frequently the data should be refreshed, or the index should be rebuilt. Most indexers provide change tracking if the data source supports it. By tracking changes and deletes to existing documents, in addition to recognizing the new documents, indexers remove the need to actively manage the data in your index, because they know what is the last point where it should look into. Finally, in the search part, there are several options. You can filter by using operators such as star, plus, minus to discard some results. You can filter, you can sort, you can project information, or even page over results. You can perform this look for information from either your client code or your server. If you enable cores to, for instance, enable direct calls from browsers. And finally, the search results can be rendered if we include data, if we mark it as retrievable, as we mentioned before, to show this information to our users. For instance, we can add URLs for pictures, or we can also include the keys in order to have identifiers of our information. So now let's demonstrate how to create an Azure Cognitive Search resource where we can import data, create an index, search information, and finally include it in a real web application for improving the search capabilities. For this demo, I will show you a website that I built for a community of good friends who like video games. We normally gather at a YouTube channel where we chat and can listen to video game music. I actually built a bot, which is a WPF application that communicates with the YouTube API and waits for music requests on the chat. So if I type this command, song requests, and then a song title, the bot processes the text and looks for a song that matches the search term, as you can see here. After the current song ends playing, the next song, which is the one that I requested, goes into play. What I want to show you is the website, where we can take a look at the playlist. We have more than 7,000 songs registered in our database, which, by the way, uses table storage to save all the information about these songs. So you can see we have the person or the channel who uploaded a video, the name of a game, and a song title, as well as other information such as the number of likes that this song has, when was it added, and the YouTube link where it retrieves the music. My friends reported me the other day that the search function didn't work as they would like, because it requires a specific order in the search terms. So, for instance, if I type Persona 5 and click on the button, I get the following results. You can see 24 entries. You can see some songs as well. If I add the mask term, even though there are several songs with these which contain these three terms or words, actually no results are retrieved. Of course, if I search for the specific song in the with the words sorted, I will get results. The main problem is in our code. The search function, as you can see, is very basic. It only uses contains. So it doesn't allow to search for words regardless of their position in the title. So let's solve this problem with Azure Cognitive Search. Let's head to the Azure portal and click on Create a Resource. Now, let's find the Azure Cognitive Search service and click on Create. Now, let's fill in some data. First, normally the subscription would not matter at all in case we have more than one. But since we are using the table storage where all the information is saved, we need to be sure that we use the same subscription in order to find later this table storage data source. So I make sure that this is the one that I need. We can create a resource group, a new one, or select, in this case, one that I already created for this demo. Next is the URL or the name of this search resource. So I will use video game music. It has to be unique or universal, so no one else is using this one. Location is, I will use US Central, since most of the users or friends are located in the US. And finally, for the pricing tier, I will stick with the free one because I consider that it is enough for these demo purposes. Of course, I can select or change the pricing tier later in case I need more resources. But for this time, 3 indexes, 3 indexers, and 50 megabytes of storage for my indexes are okay. Next up is the scale. For the free tier allows me to only have one replica and one partition. So in case I need more, I need to select another one, another pricing tier. So I will keep this one. No tags for the moment. And Azure validates that the parameters are correct. So let's click on create and wait for Azure to provision these Azure Search resources. It shouldn't take too much time. As you can see, it is already created. So now we click on go to resource, and you can see in the overview that we have an insight about the storage that this search resource uses, the indexes that have been created with a maximum of 3, same for indexers, data sources, and the rest of the information. There is also useful data such as the URL that we will use later when we integrate it in our the search in our website, and also we have the keys that we'll use later. For the moment, let's go back to overview, click on import data, and select an existing data source. In this case, it's an Azure table storage. The name of this would be video game music song. For the connection string, we will select our connection that we already have. This is the one that I use for my table storage. The table name is all songs. You can see it here. And I don't need to set up a special query for the moment, and the description is optional. So in the next part is the cognitive skills. I don't need to add song for the moment because it is a search for text. In case I have pictures, images, PDF documents, maybe it would be useful if I add a cognitive service resource, for instance, a vision, computer service, and well, you can also add other interesting skills in case our data source contains categories such as organization names, people names, or even if our data source is in different languages. But since this one only uses English, it's okay for the moment. Next up is the customized target index, where you can see that all the fields of my table storage have been detected. So, but first we will set up an index name. We can use Azure Table Index, which is the default one. For the key, I will select raw key because I know that it is unique among these data. There are no songs with duplicated raw key. Normally, this key attribute or field is automatically added, but for this I don't need it because I don't even have it. So let's make sure that you delete it in case it is included. Otherwise, the creation of the index will fail. And the rest is to set the attributes on the rest of the fields. So I would like all my information to be retrievable, but it is not mandatory. Maybe you don't want some particular property to be returned. For the filter options, I will select partition key, route key, original game, original title, and that's it. We can sort the information by partition key or route key, and the facettables categories normally would be the categories or even numbers. So I will set this one for counter, which is the number of times that a song has been requested, the number of likes that this song has, and also the original game. So we can organize songs by game. And for the searchable, I will use original game and original title. You can see in the analyzer that you can select the standard Lucene or the Microsoft ones specific for languages, and there are several also for Lucene in specific languages such as Korean, Persian, Spanish, and so on. We will use the standard one, and I think that's it for this part. For the indexer, we would like the indexer to be created only once or on demand. It means that manually we can request the reindexation of this table. But let's say that in our case or later, I can change this schedule. In my case, I would like it to be weekly because normally new songs are added into our playlist every week. So I can even set up that here in the interval part, and also when should this, the very first index should be created. But for this demo, I will keep with the immediate creation of the index. And let's submit this workload to the Azure cloud. So now we wait, and we will get a message here. The work is in progress, and we can see how is it going here in the first link. We can monitor, we can refresh for the activity. And it will take a while to successfully index all the table data. As you can see, it has finished. It took around 13 seconds to process 7,000 documents, around 7,000 documents. Yes. And well, now we can start testing this index and making some queries. We can even run again the indexer, so it will rebuild it. in case that we added new songs or we deleted some of them. One advantage that the cognitive search index has is that it doesn't need to reprocess or reindex all the table because it keeps track of the last version of this index. So if I include 5 new songs, only those 5 will be indexed. And of course, it will take less time. Also, in our notification, we got this message. When the indexer finishes execution, click here to start searching. So let's test it. You can see as well that this index takes more than 2 megabytes in storage, which is okay because we have 50 megabytes to spare. And every row or every song is known as a document in the cognitive search. So I can do a very simple query such as star in order to retrieve all the information, but the Azure Cognitive Search service doesn't return all the rows in the first search. Actually, it works with the skip and top parameters. It retrieves the information in batches. So now let's test a new one. You remember that we have this special search, Persona 5 mask. Let's click on search, and you will see that there are some songs with the title that we really want. Now the search is smart because it doesn't take into consideration the position of the terms in this search, but it behaves as a search engine like Bing or Google. It doesn't matter the position if the term exists in the game or title, it will be retrieved in this result. And another advantage is that if at least one of these terms exists in a song, either game or title, it will also be retrieved. You know, it is the same as we obtain in our internet searches, but of course, the more relevant or the ones with a higher score are retrieved at the beginning. If we would like to only keep 3 or 5, we can do that by using the top parameter, let's say 4, search, and only 4 results to be obtained in this search. No more. We can also add another parameter such as skip. Let's say skip the first 10, so we will obtain the 11th to 14th results. So now that our search is working as expected, let's integrate it into our website. But first, let's get 3 important elements, which are the search name, that is, in our case, video game music. So I will store it temporarily in this notepad file. Next is the keys. I only need the first one, or the primary one. And the third element is the Azure Search Index. By the way, you can see that the statistics and metrics are already live. When we created the index, we see the storage, the new index, the indexers, and also how many data sources we are using, as well as some activity here in monitoring. Okay, but I need the name of the index, which is Azure Table Index. Back to our application, I will start by modifying this constant file with 3 new elements: the name of the service, which is video game music, the key of the service, and finally the search index. Next thing to do is to add the Azure Search NuGet package into our application. So we browse and add Microsoft Azure Search. Latest version is 10.1.0. Now that the package has been installed, let's go to the Easy Custom Search class, where we will implement the search song functionality. First, we will include 3 namespaces: Microsoft Azure Search, Microsoft Azure Search Models, and also system reading task, in order to add the asynchronous functionality for this search song method. So we will need to update the definition of this function. Next thing to do is to create an instance of search credentials. So we will do this. Search credentials, and the parameter is the Azure Search key. With the credentials, we will create an instance of a search service client. Which requires both the Azure Search name of this service and the credentials that we just created. Now we will move this. Okay, we can keep it as well, and we will replace this contains function, and we will prepare first of all an index. Index client is search client. From the collection of indexes, get the one that we created. We would like to get information in chunks of 100 results. We will start with page 0, and we will control the output with the has more results Boolean variable. We will store all the results in a new collection of all songs instances. With a do-while loop, we will move through the pages of results that the search service returns. Now let's create an instance of a search parameters object with the skip and top elements declared to work with the search as we just did in the Azure portal. Now let's request to our service. Let's request a search. So we will use the index client .documents.search async, and we would like all our results to be cast into all songs collection. The search term is song, which is this one, and the search parameters we just declared. The has more result variable is very easy to set by checking if there are more than zero results, and we will save every result in the Azure Search results collection into our songs list. Remember that each row is treated as a document. And finally, we increase the page number. So in the first iteration of this loop, page has a value of 0. If, let's say, there are 300 results, we will obtain the first 100 here, because page is 0 times 100 is 0, page size is 100. Next iteration, page will have the value of 1. So we will skip the first 100 because we already stored them here, and we will retrieve the next 100, the next batch of songs, and so forth until there are no more results returned by this search. Finally, outside of this loop, we just return the song collection. We also need to modify our playlist controller and probably the quick edit controller as well, because yes, we change how we are calling our function, and that's it. Let's test it in our website in order to demonstrate that it was actually really easy to integrate the search Azure Cognitive Search function in a real application. This is our website. Let's click on the playlist menu and type our search term to check if it is working. We are now presented with the results, and we can see that actually songs with the terms that we introduced in our search are there, regardless of the position of these words in the search. Of course, we also get some other results which contains one or two of these words from our query, And well, you can see that there is a minor issue that we should solve, which is the duration, because well, I didn't consider that even though it is a string, it was translated into a date time field. But we can solve that by modifying the index and rebuilding it again. But the main topic, which was creating an Azure cognitive search resource, building an index and integrating this into a real application that uses table storage, has been completed successfully. So that's it from me. Thank you very much for your attention, and I hope that this video has been useful for you. Keep enjoying the Azure Advent Calendar, and see you next time. If you need anything from me, you can send me an email, a tweet, or check my blog for Azure, Xamarin, and .NET content. See you!